In this question, it is given that n is a positive integer. So what we can write is that n is greater than 0 and n is an integer. Okay. And we need to find out, does n have any factor between 1 and n? So say if I represent factor by f, we are asked the question that is there a value f that lies between 1 and n, and this f is basically a factor of n. Now this is a very common type of statement that are quite frequently tested when we are dealing with factors and multiples. So you need to understand this very clearly. Now when we say that we are looking for a factor that lies between 1 and n, what do we exactly mean by that? So understand that we saw two kind of numbers by doing the video lessons. We taught you that say if there's a prime number, say 2. 2 has only two factors, 1 and 2, right? So prime numbers have exactly two factors, 1 and 3. But if you take a composite number, say 6. So 6 has 1, 2, 3 and 6, right? So notice here between 1 and 6, between 1 and n, so if n is 6, you have factors 2 and 3 also that lie between 1 and 6, right? But when you look at prime numbers, if n is equal to 2, then between 1 and n there are no there are no factors here. If n is equal to 3, a prime number, notice that between 1 and 3 there are no factors. So if the question says that does n have any factor between 1 and n, what they're indirectly asking you is whether n is prime or composite. Think about it. If n has some factor between 1 and n, then it will be a composite number. If n has no factor between 1 and n, then it will be a prime number. So if we can figure out whether it is prime or composite, we will be able to answer the question whether n has any factor between 1 and n or not. Okay, so keeping this in mind, let's analyze the first statement, which is n has more than 2 prime factors. Okay. If n has more than 2 prime factors, then that means that n can be written as something like this: p1 to the power a into p2 to the power b into p3 to the power c, and so on, more than 2 prime factors. So it could have prime factors 1, 2, p1, p2, p3. Now, if n is such a number, then it is very clear that n cannot be a prime number, because a prime number is something which is just composed of one prime value and the power of it is 1. For example, 2 here. 2 is simply 2 to the power 1, 3 is simply 3 to the power 1, 5 is simply 5 to the power 1. The moment we add another prime number here, it becomes a composite number. So for example, n could be, just for the sake of explanation, it could be something like this: 2 to the power a into 3 to the power b into 5 to the power c, something like this. And even if the power is 1, just 1, that is enough to see that n will be composite, right? So the moment we read this, it has more than 2 prime factors, we should be able to infer that n is not a prime number, it is a composite number, and hence the statement 1 is sufficient to answer the question. We can confidently say that yes, if it has more than 2 prime factors, then there is definitely a factor between 1 and n. So if out of these 5 DS options, we can, if statement 1 is sufficient, then our answer has to be either A or D. So we can eliminate answer option B, answer option C, and answer option E. Okay. Now let's look at the second statement. The second statement is that n lies between 10 factorial plus 1 and 10 factorial plus 4. Okay, so let me just make some space here and move to statement 2. Let me write it here. So n lies between 10 factorial plus 1, 10 factorial plus 4. Now we know that n is an integer. So if lies between 10 factorial plus 1 and 10 factorial plus 4, n can be either 10 factorial plus 2 or 10 factorial plus 3, right? It cannot be 10 factorial plus 4. It can only take these two values. Now look at this and think, is n a prime number or is it a composite number? Now you might be confused, and if you just literally look at these values, you might not be able to figure out what it is. But you know that 10 factorial is nothing but 1 into 2 into 3 into 4 into we can go until 10, right? And plus 2. Now we can take out 2 common, right? We can take out 2 common from these two, and we can say that 10 factorial plus 2 is nothing but 2 2 into, since we have taken 2 common, we'll write 1 into 3 into 4 till 10. And since we have taken a 2 common from here, plus 1. Right? Now notice that n, 10 factorial plus 2 is 2 into something, and this something is not 1. This is 1 into 3 into 4 into 10 plus 1. So this is some actual value. And we have already told you that if a prime number is written as 2 into 1, apart from that, if you have anything apart from 1 here, say 2 into 3 or 2 into 5 or 2 into something, then that number becomes a composite number. So we are sure that 10 factorial plus 2 is a composite number, right? Similarly, if you look at 10 factorial plus 3, even this can be written as 1 into 2 into 3 till 10. And we can give this the same treatment. We can take 3 common from this and say this is nothing but 1 into 2 into 4 into something till 10 plus 1. If you multiply back, we'll get the above term. But the idea here is that 10 factorial plus 3 is 3 into something, and this something is not 1. So 3 into, say, k. So obviously this is if n is 3 into something, it is not a prime number, it's a composite number. So now a very interesting thing here is, see that in statement 2, we don't know what n is. We don't know whether n is 10 factorial plus 2 or 10 factorial plus 3. But are we asked the value of n? No, we are not. We are simply asked whether n has any factor between 1 and n. And for that, we just need to figure out whether n is composite or not. In this case, if n is 10 factorial plus 2 or 10 factorial plus 3, both of them are composite. So we are not worried what n is as long as both of them are giving the same result. So whatever be the value of n out of these two, it is going to be a composite number. And that is enough for us to answer that n definitely has a factor between 1 and n. And since we are able to answer from statement 2 also, the correct answer in this case would be option D. So once again, the purpose of this question was to help you learn how to make logical deductions. Sometimes you'll be given something, a question like this. If you're able to infer logically, then you will be able to understand what exactly are you looking for. Like in this case, we converted this question, which was based on factors, and we summarized it and said, hey, to answer this question, we just need to figure out whether n is prime or composite. Those of you who were not able to make that inference, in those cases, you may have ended up ignoring statement 2. Some of you may have been able to solve statement 1 because that was slightly easy, but to answer the question especially with its prime or composite, it makes sense to instead of solving it all these values and getting the answer, it makes sense to make this inference first. So those of you who are not making this inference, you may end up wondering what to do with these values. Okay.